Hey guys, today we're going to continue with our geometry and similar triangles, but we're going to put a little twist on it. We're going to talk about similar triangles on a graph. So let's really quickly review what similar means. Since we're going to be dealing with triangles, I'm just going to talk about those, but it applies to all shapes really. Something is similar if it has the same shape, same proportions, same angle measurements, but different sizes. So if I had these two triangles, as long as they're the same shape, the same proportions, and have the same angle measurements, they're going to be similar. It's okay that they're different sizes. Versus congruent triangles are an exact copy. Everything, and I mean everything, is the same. Angles are the same, proportions are the same, they're the same shape, they're the same size. If I put one on top of the other, it would look like one. Now, here's something I bet you guys didn't know. Similar triangles can be found along a linear equation when it's graphed, or be used to find the slope of a line. And today what we're going to be doing is actually just plotting triangles on a coordinate grid and then determining if they're similar, congruent, or neither based on the equation that they make or don't make. So let's move on into our steps. Okay guys, let's really quickly go over some steps. So if I'm determining if triangles are proportional along a grid, there are some steps I have to go through. The first one is to plot the triangles. The second one is to extend the hypotenuse so the triangles connect. And hypotenuse is just the longest side of a triangle. So if I'm given this right triangle, my hypotenuse is this side here. It's by far the longest side. Or if I was given this obtuse angle, this obtuse triangle, the longest side here would be the hypotenuse. The third is to find the equation of the line if the two triangles are on the same line, or the slope of the hypotenuse of the two triangles that you're given. If the equation is the same, let's say you had two triangles and the equation came out to be y equals 2x plus 1. If that equation is the same for both triangles, then those triangles are congruent. If the slope of two different sized triangles is the same, the triangles will be similar. So we're going to go through examples like this. So let's move right into one. All right, really quickly, we're going to review determining if figures are similar. Figures are similar if their proportions turn out to be the same. So I have these two triangles, and all I'm going to do is I'm going to set up a ratio. And remember, a proportion is a comparison of two ratios. 3 goes with 6. I'm going to set that up as a ratio. Now, I'm going to try to just simplify it down to its smallest form by dividing by 3, because I can always compare by getting it to its simplest form. 3 divided by 3 is 1. 6 divided by 3 is 2. So this first one has a proportion of 1 to 2. Now, I'm going to set up my next one, 8 and 16. Again, I'm going to divide by 8 on both sides. I'm going to get 1 and 2 again. Now, since these proportions are the same, these figures are in fact similar. Now, let's try this on a coordinate grid. Okay guys, let's look at this first example. I have two triangles, triangle ABC and triangle XYZ, that I've already plotted for you. Once we move into guided and independent practice, you will have to plot these triangles yourself, but I figure we don't need to work on that skill. We should already have that. Now, I have these two triangles here. Since they've already been plotted, my next step is to extend the hypotenuse, which is the longest side of these triangles, to create a line. So let's go ahead and do that. Now, my next step is to figure out if these triangles are similar or congruent. Now, if they're congruent, their equations are going to be exactly the same. Not only where their slopes will match, but the equations of both of those lines will end up being the same. So let's just start out with triangle ABC. Now, just to be clear, I'll know that these are congruent if their slope is exactly the same the first time without having to be simplified. And these triangles look like they're probably going to be congruent. But let's go ahead and find the slope of the hypotenuse from triangle ABC. So I'm looking for the slope between points A and C. So again, that's just going to be rise over run. Let's see how many times I rise. 1, 2, 3. I have a rise of 3. and a run of 1, 2. So I have a slope here of 3/2 x, and then I see that this line, which I've extended, this line that I've extended here has a y-intercept of 2. So I'm going to add that into my equation. Now let's do x, y, z. I'm going to find the hypotenuse of, or the slope of the hypotenuse from x to z. So I rise 1, 2, 3, rise of 3, and a run of 2. So since both of these triangles fall on the same line and have the exact same equation and the same slope without having to be simplified, that means that they are congruent. I could place these two triangles on top of each other and they would be congruent. It's only if I had a larger triangle like this one would end up having the same slope as these two triangles once it was simplified, but it's obviously larger, so it wouldn't be congruent. All right, let's do another example. Hey guys, let's look at number 2. I have two triangles that have already been plotted and their hypotenuse extended to create this line. I have triangle EAC and triangle FBD. What I'm interested in is understanding and figuring out if these triangles are proportional. And the way that I figure that out is finding the slope of the hypotenuse of these triangles. So finding the slope of the hypotenuse of AC and the hypotenuse of BD. If their slopes are the same, the triangles are proportional. That's the big thing we need to take out of this lesson. So I'm going to go ahead and just find the slope of triangle EAC. So again, I want to find the slope of the hypotenuse. So I'm going to find the slope from point A to point C of this triangle. And the way that I do that is just rise over run. So let's see how many times we rise. 1, 2, 3. I have a rise of 3. Let's see how many times we run. 1, 2, 3, 4, 5, 6. If I reduce that down by dividing by 3 top and bottom, it comes out to 1/2. So triangle EAC, the hypotenuse has a slope of 1/2. Let's do the other triangle. Okay, now I want to find the slope of the hypotenuse of triangle BFD. So I'm going to find the slope from point B to point D. So again, this is just rise over run. If the slopes are the same, these triangles will be proportional. So let's see how many times I rise. 1, 2. I have a rise of 2. How many times do I run? 1, 2, 3, 4. If I reduce this down by dividing top and bottom by 2, I find that I have a slope of 1/2 as well. Now, that means that since the slope of the hypotenuse of these triangles is the same, these triangles are proportional. All right, that's going to be it for me today, guys. Let's practice.